Hello, grade 12. Yes, I'm back once again. This is a developmental exercise, isometric drawing from one of the workbooks. We are given the front view, the top view, and the left view. We are given the front, the top, and the left. Front, top, and left. Third angle orthographic projection. Remember, paper 2, isometric drawing. Paper 2 is in third angle orthographic projection. Paper 1 is in first. Now, position of point P on the drawing sheet. Position of point P, this is where we're going to start, some sort of isometric grid. And what else? Instructions. Using scale 1:1, convert the orthographic views of the tool part into a sectional isometric drawing on cutting plane AA. There is a cutting plane AA. It has been cut here. That part is going to be removed. Make P the lowest point of the drawing. Here is point P. Point P will be here. It will be lower. The rest will be up there. Show all necessary construction. No hidden detail is required. Right. I go very, very slowly. To some of you that are sharp, it would be necessary for you just to fast forward this. If you feel that maybe we are delaying you too much, you can leave us. Here we are also catering for learners who are very, very slow. Learners who fought a long day to the first time. Learners like myself. I used to be that learner when I was taught this stuff by Bareki from Dinoto. That was the guy who taught me how to do some of these drawings. I was a slow learner. That is why I go very, very slowly, so that those who do not understand, maybe they might gain one thing or two. It's a 3D drawing. One dimension, another one. 1, 2, 3, 3D. So I'll create a box where this drawing will fit. The length is 120. On the left side, it's 90. It's 120 and 90. There we go, 120. Let's check there, 120 and 90. From time to time, I check on my drawing. I want to be as accurate as I can. 120 and 20 there. 90 will be there. I have 2D now. I've got 2 dimensions. Now I'm looking for the third dimensional, which is the height now. I do have the length and the breadth and the height. This will be my height. But this part that is at the bed, that part, it will be my height. How high is this? It is 90 by 90, which means it's an equilateral triangle, 90, 90, 90. So I will need to draw, I will have to draw what they call an auxiliary. For that, just to look for my 90, maybe I start here. I will measure 90 for the width. I will measure 90. There is my 90. It will be my 90 here, there, and I will do that. I will do that. It doesn't show over there. My 90. Again, this is my 90. I made an arc there. I put it on my 90, another 90 there. Where the two intersect, it will be my equilateral triangle. There is my equilateral triangle. This equilateral triangle, I want its perpendicular height. That perpendicular height There is my perpendicular height of my equilateral triangle. So that height, it will be this one here, which is 10 plus the one that I've just measured. It's 10 plus this height. I will start with the 10. Here is the 10. I will start with the 10. There is my 10. Let's run with the 10. 10 goes that way, and my 10 goes also that way. And then the height is that one, this height, yeah, perpendicular height, it is that one there. That is my height. So I've done with my 3D. Now I can complete my box. This box that I'm drawing here is going to assist me, because everything that I must draw now, I know it must fit into this isometric box that I have. From my 120 here. Okay, yes, yeah, and then this side, I will have this point there, it goes up to that side, and then from that end, with my set square, I'm completing my isometric box here. Completing my isometric box. There is my isometric box that has been completed. I also need to have my center. Why do I need a center? In most cases, center line is very important, because you'll find that in most cases it cuts through the center. When you look at it here, you have this side. From this center there is 32 and 32, and there is this gap, which means here this side is 90. It's 90 when you look at this object. Although here it is not shown what is this distance from here to there. I'm trying to look at it from every angle of mine. I seem not to get it. Because this one from the center, it indicates those holes. But since that is 90, you look at it from here. It is the center. This part is that part. That is the center. Since it is the center, the cutting plane passes through the center. And it passes through the center of this web. This web here. This is the web. Here it is the web there. Cutting plane, it starts here, it passes through that web. It is at the center from that side, which is from this side. The cutting plane is at the center. And also here, when you look at it from this end, you will see you have a 20, and then you have another 20. This is 20, 20. Why is this one 20? Since this is 80 plus 20 is 100, the other one there, it will be 20. Okay, all right. And then from the 20, this 20, it is this 20 plus 10, that 10. It is this 20 plus 10 plus 30. 30 plus 10 is 40 plus 20 is 60, which means from here to there, it is 60. We have it as 60, which is half. So it is half here, half that side. Now, let's do it. What I'm talking about is this. When I say it's half, it means it's this stuff here. 120, half of 120 is 60. Half of 90 is 45. Don't lose me now. have my box here. I don't worry about many things. Many lines are going to confuse me. This is my center. Just want us to have just a good perspective of what we are doing here. Center. My center goes over to the other side. Let's go to the other side. Center. And then there is this center from that side. And sometimes it's difficult to understand this stuff. If you do not practice, HET you don't study, practice. But once you practice, it becomes alive. Start seeing other things that ordinary people do not see. So, which half is being cut? It is this half. This part is removed. We remove this part. Let me show you exactly. I go slowly with you. Bear with me. If you are fast, leave me. Leave me. Taking other students along. You can go fast forward to this stuff and go where it suits you best. There we are. I am showing you this one. It's like that. So this is this quarter. This quarter is being removed. Going to remove this quarter. There will be nothing here. So I like drawing my drawing from this end. From this end. Since this one, why in this one? It's like a bus or a car. It's facing that direction. So isometrically, it will be that direction. So I'll take it from this end. Start drawing it from this end, moving backwards. Because if I start from backwards, I don't know which part will be visible from the front. But if I start from the front, I might draw parts that will be invisible if I start from the back. Then it might confuse me a little bit, whereas it won't be necessary to draw those parts. But if I start it from the front, because this part is the one that is nearer, I'm definitely sure that this part is visible as I move backwards. It is much easier. Now I will start. I want us to talk about the web first. This is the web. Impumulo, the rib, the nose. This is the web. It's long. It goes right through. There it is, dotted line. There is that web. It goes right through. It ends there. It ends here. The web. So this web, when you cut it across, you cut it there, cut it that direction. You show the sectional lines of the web. But when you cut it along, which means you're coming from that direction, you cut it, you move along with it. This web is moving that direction, you move along with it. You cut it this way. A web, you don't show sectional line when you cut it along. But when you cut it across, and you are looking at it from that end, or from that end, you show sectional lines. I'll show. You will see as we go along what I'm trying to say. Now, let's draw the web. The thickness of this web. Where is the thickness of the web? I'm trying to look at it. I don't see it indicated. Maybe you might see it. I'm trying to see. It's not shown here. The thickness of this web. I will assume the thickness proportionally. The dimension should be proportional. Proportional. When I look at it, it's almost similar as this dimension. These are proportional. I'm taking it in good proportion. That will be termed good proportion. It looks as if they are, even if I can take my compass and measure them. Sometimes some dimensions might not be given, or they might be forgotten, but sometimes you might not see them, but assume them, take them in good proportion. I think it is 10, yes. That is 10. That means it's also 10 there. I'll take it as 10. But half of this 10 has been cut. Half of it has been cut. The half of it. Which means the other side is 5. Which means from the center, I have 5. when you go the other side. It is 10. Let me show you. The web is 10. There is the web. It starts there. Just to be accurate, yeah, it starts 5, 5. That is the web. The web is 10. But half of it has been cut. Half is still there. So we're going to show you the half that is there. The half that is there, its length, this web, from here to there, here to there. This length is 20 millimeters. I'll measure 20 millimeters. It is 20 millimeters. The height is 22. It is 20 by 22. Let's do that. The web here, it is 20 the height of it is 22. 20 by 22. 20 by 22. Let's look at 22 here. That will be the height of the web. It is not isometrical, so that is the height of the web. So this web will be here. I will be able to see that web there, and also this part I will be able to see it. I want to take it. You can measure 5 there, but with me I do parallel lines. If we've done parallel lines at grade 10, you will be able to do that with 2 set squares. It will be somewhere there. Notice that I've made it faintly because I don't know where it ends until I've done that. So now I know it ends there. Then I can have it as a solid, and then this part there is visible up until there. I know that. Just complete the parts that I know they will be visible for me, part up until there. Now what do we have next? We have done this web. Now we must do this. What is that? That is the hexagon. Here is my hexagon. I must draw my hexagon from this point. So the hexagon, I must draw it isometrically. So for me to be able to draw my hexagon isometrically, I need an auxiliary drawing, my helping view of a hexagon. And then my hexagon, they told me that each side of the hexagon is 20 millimeters. Hexagon, every side is 20 millimeters. 20 millimeters. 20 millimeters. 20 millimeters. It's 20. There is my 20 millimeters, and then I love to do it with the compass. It's much easier because every side I measure only once with my compass, and then my set square. It is also important to note that as I'm drawing this one, okay, let me not confuse you. Let me complete it first. There, and then we go that way, and that way, which will be that and that. Verify. I would love to be accurate as possible, yes. There we are. Good. Now I'm pretty sure of what I've just done here. I'd just like to make it a little bit darker so that you are able to see it nicely from my camera angle. And my camera, I must also once more apologize that it doesn't have the best quality in town. But hey, as long as you understand the stuff, that's what is important. It's not the quality of my camera. Better camera will get it along the way, guys. Along the way. You have no excuse. Hey, COVID. The stuff is available. There we are. It is going to be 40 here. Twice the size. There is my 40. And then the center is 20. At the center, it's important to get the center, guys. You'll see why. Center line is very important. And even in your perspective, in your assembly drawing, center line, there are marks there for center line. Drawing center line. Center line is a language. Center line is a language. Then, okay, we will ignore that. We will transfer it to that space there. So we want to create an isometric box for it there. Sorry for that phone. We won't stop what we're doing because of a phone. Now I'm creating this box here. Now I've shown you the center. I don't want to have too many lines. They end up confusing me. So I would love just to minimize my lines because sometimes they might disturb me. I know that I had a center line there, but when I'm drawing this, because I'm drawing it here so that you are able to see what I'm doing, just removing it a little bit for you to see and for me not to be confused for that matter. I have a center line will be at the center here. Remember there is another 5 here for this to be at the center. So this is what I do. From here to there, it's 20. There, center, 20 that side. I measure 20 also that side. 20, 20. Then I go vertically up with those 20. There is my 20. I'm trying to make a box here. Oh, it's almost there at the center. I make that box there. Ignore the center. I've talked about the center. I'm not worried now about the center. I'm creating another box here. And then I'll measure this distance to there. From here to there, it will be these two distance. 1. It will be 1, 2. Are you with me? Hallelujah. Praise the Lord. Now, we go up to where the height will be there. So, it will turn here. There it goes. There it goes there. That way. And that way. My only focus now is in this box. This box. This is that box there. That is my main focus. This center is that center. Let me show you that center there. Zwang, 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 zwang. That is the center. And then that center that goes that side there. We do it. We do it. We do it. Don't worry if you don't understand. You can always rewind or ask your teacher to explain it differently for you. Here is now my isometric box, this box for my hexagon. Now let me put my hexagon in. Isometric hexagon. Look, when I put my hexagon, this half, it's not there. but I will show you very faintly on that side. And then this half is the one that is visible. I will do this. Drawing my hexagon. My hexagon, it is this part there that goes to the left. It is that one that goes to the right. This one that goes to the right. But this side, just to show you, I won't complete the other half. I will have it there for you to know. It was there, boy. This one, it goes from the center to there. And then even up there. This one is there. And then the other one is there. But only a half of it is shown. That part, only a half of it is visible. You can see only half of it. And then this part will join at the corner, join at the corner. So this part will join at the corner, join at the corner. Just literally take your set square or ruler, you join there at the corner. It will look a little bit irregular. But remember, it is an isometric drawing. You will have that corner being like that. Now, it goes on. So I've done that part. I'm taking it further now. We are looking at the hexagon. The length of that hexagon that we've just drawn, the length of it is 80. That hexagon will go a length of 80. 80. Let's take the hexagon. You ignore any other thing now. You ignore. I'm concentrating on the hexagon. Hexagon at the edge there, at the corner there. That line must be 80. That's what is important to me. Is that line that I've drawn isometrically there, that line must be 80. 80 that parallel. Because that is the length of my hexagon. There is 80. My focus is on my hexagon. There is 80 on my hexagon. There is 80. Fine. My hexagon will end there. But now I need to put my circle here also. But I only put half of the circle. So what is this? Where is the circle? Let's go with it. Here is the circle. The diameter of the circle is 25, so the radius is 12.5. Let's take the radius, 12.5. Look at what I'm doing right now. Hopefully you have done isometric circles in grade 10. 12.5. There is 12.5. Do you see it in room? Yeah, 12.5. There is my 12.5. I measure 12.5. 12.5 is there. 12.5 is there. 12.5 is there. All four corners, 12.5. Make a box, isometric box. Box. Isometric box for the circle. Making an isometric box for the circle. Where my circle will fit. My circle will fit. There is my isometric box. Hey! What's wrong with this guy? Oh, my set square is not flat. Right. Here is my isometric box for the circle. Here are my center lines. I'm also going to teach you again if you have forgotten in grade 10 your work, but I won't dwell too much. From this corner, move from this corner. This circle is on the left hand side. I move bottom left and top right. That side. From bottom left, I go to the center. and then I go to the other center, and then from the opposite direction I do the same. Go there, I go there, and then I take my canvas. It's here, I put it here, put it here, and then I take that length, it is that length there, I do that, this is part of the circle, and then I will take it to the opposite direction, but it is an arc, semicircle. It's an incomplete circle. Right? I will take that part there and see if it is aligned well over the other side. Look there. There we are. There he went. Right, you have your arc, your circle. How long is your circle? Your circle, look, your circle goes up until here. Here is your circle. It goes 28 millimeters. Your circle inside. I win. Inside your hexagon. 28. I will measure 28 now. Concentrating now on the circle because it will be visible. It's cut. Half of it has been removed. Now it goes in 28 millimeters. 28. Right. There is 28. My circle will end there. My circle will end there. Sorry guys, so many stuff happening here. My circle will end there. So my circle will end at 28 millimeters. It is 28 millimeters deep. So this part of the circle will be there. I need not to construct also there. I've already constructed. I have my marks for construction. I'll have another mark here for constructing that one. But I don't have to construct it. I can just manipulate. This one was drawn from here, from this corner. So isometrically, I move backwards. I'm moving backwards from this corner. I move backwards by 28 because it's 28 millimeters. I'm going to move back 28 millimeters. I have moved back 28 millimeters. Look at this trick here. This one was drawn from this point there. We did that one. So where it ends 28 millimeters backwards. I put it there. Here is that line. It ends there. I'll do that. It ends there. It will end there. My circle will end there. There is my circle. But let's look at the hexagon. Where does the hexagon end? The circle now, we know it ends here. That is the end of the circle. We're done with the circle here. 28. Nala Pezul 28. Circle ends there. 28. Hexagon goes on. That has been cut. Remember, hexagon has been cut here. It goes on. How long has this hexagon been cut? Let's look. Hexagon starts here, it ends there. But halfway line here. From here, it is 60. 60 minus 20 is 40. From here to there, it is 40. Are you with me? Again, from here to there is 60. The whole length is 120. 60 minus 20. It will be from here to there, which is 40. 60 minus 20 is 40. So it will go 40 millimeters deep. Let's measure that 40 millimeters deep. The hexagon will go 40 millimeters deep. There is my 40 millimeters for the hexagon. It ends there. The part that has been cut, it ends there for the hexagon, 40. Now, let's complete my hexagon now. Let us complete my hexagon. We said the hexagon is 80 on the other side. Where is my 80? We said our 80 ends there for hexagon. The whole length of hexagon is 80, it ends there, that part. And then it has been cut 40 millimeters of it. There is that 40 of a hexagon that has been cut. The other part will go back this way. For how long? For how long? Let's check. When we're doing hexagon, we said it ends here and there. Just for you, man. I will do is let me use a pen. Remember, if the hexagon was not cut, throw that part. This side. I'm using a red pen. This side is not there. It has been cut. It has been cut. But suppose it was there. Suppose it was there. It will be like that. And my hexagon will be complete with its circle there. And then from there, that corner would have gone upwards there. Don't know for how long. Even this one would have gone upwards there. I don't want to take it fully. How long? This part that has been cut, it will have gone 40 millimeters. 40, because we said it's 40. It has the part of a hexagon that has been cut is 40. Now it would have gone up until here. It would have gone up until here. The part that has been cut. It would have gone up until here. It's 40. Every corner is 40. It will have gone up until here. That is 40. Even this one, remember, even this one, it could have gone up until 40. Where is my 40? It will have gone up until there. Then you join these three. It will have gone up until there. Now, it's either you join them like that, or you use two set squares. Making parallel lines like this. You know how to draw parallel lines. You see now. You get it. It will be there. It will be there. It will end there, and then it starts the real one. Now there. Even that one. Make a parallel line. This one here. This one. You can do it this way, but already we have measured it. It's not necessary for me to do it this way because it has already been measured. But if you only measured once, you will need to do that, and then you slide. Wait, my compass is jamming somewhere. I don't know what is disturbing. You see, they will join there. So that was the cut surface. Something sticky. And then this part, now we are able to see it because it has been cut up until there. It has been cut up until there. We will go up this part. We'll go up until there. I'm sorry, I will not pick this up. I'm busy. That one there, which simply means the bottom line here will be here. It will go up until there. No, it won't go up until there. I will tell you why. It has been cut. It's fine. It's cut up until there, and then isometrically the top part. I'm only now concerned about the hexagon. The hexagon, I'm completing the hexagon there. There is my hexagon there, and then this side, it must also go backwards. That one backwards. By how many units? If you don't want to do parallel lines, you will just measure this. Just measure this. This remaining part. This remaining part, it will be here and there. And then you will have to join. This there and there. Other parts is done this way and that way. So this thing has been cut up until here. It has been cut right through up until here. So we'll have to close it here. But the circle, it ends there. Circle ended up there. And the hexagon, that is the part of the hexagon that has been removed. Now, coming to another very important serious matter. I am extending here. One. Remember, there is another 10 millimeters. It also goes that side. Here is it. There. It joins that one. Don't lose me. Stay with me here. Stay with me here. Remember, we've taken 5 here. There is another 5 that is there. Where is that 5? What happened? The 5 that has been removed, it has been removed up until here. That 5. That 5 has been removed up until here. That is that 5. Still there. It is going on. The 5 is going on. But now it has been cut from that end. That web has been cut from the other end. It has been cut from that end. Stay with me here. Stay with me. Stay with me. Stay, don't lose me. Right. That web, it's only one web here. This web here. Okay, this is the part of the web. Wait. Right, I want you to see something. Something I want to show you right now. This is the 5. The other 5 is there. When looking from the left, the remaining 5 is there. There is another 5. So that 5 was cut along, longitudinally. But we also cut this way. But when we arrive here, we cut it across. Since we have cut it across, we can section it now. So la, we section this part because we've cut it across. We have cut it across, so we section it. We section it, and then there is this part also. Where is my red? This part here, this part in the middle here, because it's cut. It's one component to the stuff. It's not two. It's just that the sectional lines, they tell us, they inform us of different directions. So why am I drawing these lines? Because I'm not going to section the web here because I've cut it along. But now here on this side, I've cut it across. So this is how things are gonna look like. Here I will section this part that has been cut from that end. You don't want to keep them very, very close, your sectional lines. You'll spend a lot of time sectioning. You don't want to spend too much time doing that. Starts here. Oh, this one, as I was sectioning it, the whole of this part, as it goes on, it touches also that, this one, this part, that one, that part, then here. Notice that I don't section the part of the web, I section the part of the base now. This is the base that I'm sectioning here, not the web, the base. I'll section the base. Now the other one, because I'm going the opposite direction now, it will be like this. Although it's still the same component, but now opposite direction. This line is not there. I call it a line. I think I need to remove it. I need to remove it as soon as now. It's not there. It's not there. We'll remove it. Where I've made a mistake, they will rectify. Abu Shabalala la Peace Springs, Abu Malulega li Eliondile, no Mahlang, babona ma mistake but le parenzana. Okay. If there are any mistake, I don't have a memo with me. Hi man, rectify them with your teacher. Or find them by yourself. There it is. Now that part, we are moving backwards now. We're moving backwards. Remember, we also have that. This is the part that I just wanted to talk about earlier. Remember, when we're doing this auxiliary drawing, 60 degrees. If 60, when you do it like 60, you will see this also will be 60. That's another way of doing it. But I saw that it was a lateral triangle without having to look at the angles. The thickness of this triangle, the thickness is 20. It's 20. 20. Let's look at the thickness. Its thickness is 20. There is the thickness, 20. Thickness is 20. It goes right to the center. Here is my center. Set it goes to the center. That 20, it goes to the center. Hey. So I will draw the inside line. This 20. I will join it. There is my 20. That side. There is my 20. There will be a gap here, smaller gap. It goes to the center. I think it will leave a smaller gap here. Something is slightly wrong to leave a smaller gap here. Why I'm saying that? When you look at it from this side, there is that gap I'm talking about. So I might have just gone slightly overboard here with my foot. Yes. Yeah, yes. Like I'm telling you, there is my foot. My foot is here. My foot is here. Boy! Hey, if you find something, if an enemy is caught, it's being removed. It's been removed from the equation. There is my foot. I know there is a gap that it must leave, as you can see from the left view. This thing is there, but you measure when correctly and accurately. It's there. Yeah, there is my accurate point there. It's there, not that one there. It's easily. No paisa, man. Like I told you earlier, I was not one of the smartest students, but at least I think it's much easier for learners to understand what I'm saying, because I take them very slowly. Then keep on practicing, get it right. And then remember, it will go down to the other side. Where will it go? We do that. Do that. This will inform us where it ends there. There we are. And then this is the part of the web that goes up. And then that side will go back that way. That way it will meet with this part there. Where will they meet? Look. Trying to find out where they can meet. Somewhere there. Somewhere there. They will meet up there. Since they meet up there, then I know I will join this one there. Where the two meet, it will go down that way. Then you will have it that way. Going on the other side. Now you would want to put these 4 holes that are giving us trouble. They told you that this one is 20 millimeters away. That is 20 millimeters away from the center. From the center to the outside is 32. From the center to the outside is 32. Let's look at the center. From the center to the outside is 32. We go 20. Here is our 20. We did it earlier. From that 20 center, as we come back 32. From the center, we come back 32. That side 32. Take about 32 bit now. Thirty-two. Right? I'm taking it backwards that way. somewhere there. The other one will be there. I take it backwards there. And then we are told that it is 14 each side here. This one is 14. It's 14. So we'll measure 14. Coming back. 14. There is my 14. Oh, it's not there here. 14. Coming backwards, it's 14. There is 14. Look, this 14 it's not for here. I'm looking at that other side. This one here. Go there. There. How big is each of those? If that is 14, I think it is a square of 14. 14 that side, it will be, yeah, 14. It is a square of 14. Although there's nothing that I can tell that proves it for me. Sometimes if you don't see those measurements that you want to see, you just manipulate them. I don't see this other 14. I know that this side is 14 on a different scale. I'm checking here. You see, it also gives me 14. It will be 14. It's a square. Although I don't have time now to check with I will make it that 14. 14, Baba. 14. Make that 14 there. 14 there. It will be there. And there it will go deeper. By 10. Goes deeper by 10. 10. Isometrically. Only do that one. Yeah, do everything, Baba. Do everything. And I won't do everything now. Only gone almost an hour now. And then we have to do that one. That is at the back. There are marks there, guys. Remember, please remember, there is 30 from here to go when you go at the back from the center. From the center, you measure 30. You will measure 30 from the center. And we know the center, our center is here. So where is our 30? I'm so tired. But 30. And then 14 is there. There is my 14. Then you're done. 1, 2. Do everything, Papa. Everything. You go by that. It's there. Take it this way. I hope you have enjoyed this one. If there are mistakes, that's smaller mistake, fix them if you find one. Yeah, there we are. It took us an hour. Praise the Lord, it's done. Thank you. See you in another video. I hope you have learned something. Thank you, guys. Cheers.